So we'll do a few more examples. So we'll start off with one that was similar to something we did already, which is both sides have a radical on them when we start the question, and then you're going to square both sides. And when you square both sides, you could put them in a bracket and write the squared, or just put a squared on the end of the square root. Either way is fine. So 3x minus 4 is equal to 11 minus 2x. And then you solve your equation. Your 2x, your 4. So 3x is already on this side. The minus 2x becomes a plus. 11's already on this side. And moving the minus 4 becomes a plus 4. 5x equals 15. Divide both sides by 5. X equals 3. So the answer looks good when we plug it in to check. So what I would suggest, if there's an x on both sides, when you check your answer, do left-hand side, plug it in, get an answer. Do right-hand side separate, plug it in and get an answer. And just make sure that they're the same. So the left-hand side was 3x minus 4. And if we're checking 3 times 3 minus 4 is 9 minus 4. Square root of 5. And it doesn't matter if it works or not to a nice number. It just can't be a negative under the square root. Okay? And then the other side, if we plug it in, so the right-hand side, 11 minus 2x. So 11 minus 6, which is square root of 5. Say they're equal. So x minus 3 is the answer. Okay, so we can have radicals mixed with rational functions. Oh, sorry. So we can mix them together, but it's the same thing. If we've got a square root, it's isolated, which means it's by itself on one side. We can square both sides to get rid of that square root. So if we square both sides, we will have x over x minus 3 is equal to 1. And then what? Cross multiply, because it's a fraction, and that would be our technique. So we would move the x minus 3 to be multiplied by the 1. Now we can see maybe right now that it's not going to work because the x has the same coefficient, the same number in front of it. When you move that x over to this side, it becomes a negative. And there's nothing to check, there's just no solution. Okay, so we can have no solution in that the answer we get, we plug in and it doesn't work, or we could have no solution right away that the x's cancel and there's no answer. Okay, so number 3. So in this section of the course, if you've got two radicals in the equation, the third term is always going to be 0, just in this section, okay? It does become more complicated if that were a number not 0, okay? We end up having to do a quadratic. So just in this section, that's always going to be a 0. So what would we do here? We've got 2. And before you square one side, you have to isolate at least one of the radicals. So we would move this one over to the other side before we start. And we would have root of 5x plus 1 is equal to root 3 minus x. And then the same way, square both sides and solve. Move the x and move the 1. 5x stays plus x. 3 stays minus 1. 2 over 6, which can reduce to 1/3. So it's a fraction, but we still have to check our answer, but we know how to plug in fractions because we did that section already. So check. And again, I would just do left-hand side and right-hand side. If you don't, you have to keep writing both sides the whole time together if you don't do them separate and then compare. And sometimes the expressions are complicated. So we've got 5x plus 1. And the other side that we want to be equal to is 3 minus x. So I would just plug them in separate and see if you get the same answer. So we are checking the solution 1/3. So 5 times 1/3 plus 1. It's 5 over 3 plus 1 as a common denominator of 3 is 3 over 3. 8 over 3. And you could break down the 8, but I wouldn't bother until you see what you get for the other one. Because if it just looks like this, you can stop, because you're just checking that they're the same. We did one last class that we actually had to break this up to a mixed radical. Break down the 8 into a 4 and a 2 and so on. But we probably don't need to do that. So that's like a 3 over 1, so that if we multiply that by 3 over 3, we get 9 over 3 minus 1 over 3, which is 8 over 3. These are equal, therefore x equals 1/3 is the solution. And just for anyone that wants to see how to break that down, because this would be a legitimate question, is to simplify a radical. 8 divided by 3 doesn't work, so you can't simplify that by itself, but you can do the square root of 8 over the square root of 3. 8 is 4 times 2. And so this is the square root of 4 times the square root of 2. And now what? Square root of 4 we know is equal to 2. 2 root 2 over root 3. So this would be a possible answer. Sometimes they've taught you how to rationalize the denominator. How do we do that? What if we didn't want a root on the bottom? This is fine. This is an answer. Okay? And it's the right answer. You could also write this as 2 times the root of 2/3. Do you see that that would be the same? Because you can put the radical over both. Now, if they wanted you to rationalize, do you remember how to do that? Just a new question, okay? Not the same question, but say we want to rationalize the denominator. First of all, what does that mean? It means get rid of the root, leave your answer without a square root on the bottom. So how do we do that? We multiply the top and the bottom of the fraction by root 3 over root 3. Because square root of 3 times square root of 3 is just 3. That's square root of 3 squared. All right, that's square root of 3 squared. So if we do that, we'll have 2 root 3 over 3, and then that's rationalized. So if we had our question from the last page, we had 2 root 2 over root 3. How would we rationalize that? Always whatever's on the bottom. So look at the denominator and say, okay, that's a root 3. So we multiply top and bottom by root 3, whatever's on the bottom. Now on top we're going to have 2 root 2 root 3. And on the bottom root 3 times root 3, which is 3. simplify root 2 times root 3. How do you write it? Yeah, as one single radical. 2 times 3 is 6. Root 6 can't break down because it was just a 2 and a 3. There's nothing that we know the root of. So this would be the same answer. Now, why is it important to know that? I don't require you to rationalize the denominator, nor will anyone in calculus, really. If you take linear algebra, you will have to rationalize the denominator. That would be some place you would use that for complex numbers. But where I see that you might need it is sometimes you're checking your answer. So say you're studying for the final exam in this or in calculus, and you're practicing the odd-numbered questions, because in the calculus book, the odd-numbered questions have answers in the back of the book. So you practice your odd-numbered question, and then you look in the back of the book, and you have the answer, and the back of the book has something different. Oops. Okay, so this is your answer, and this is the back of the book. So how would you know if your answer is actually the same? First of all, you'd probably say, oh, I got it wrong. And then you would come and see someone, and I said, well, what if you rationalize the denominator here? What do you end up with? So how would we rationalize the denominator? Multiply by root 2. And so then on top, or in the numerator, we'll have 2 times root 2, and on the bottom, just 2. Now what happens? 2's cancel, and they're the same, right? But they look sort of very different. So that's one place to watch for, is if you're matching your answer and it has a radical in it. If you rationalize and they didn't, or vice versa, sometimes your answer will look different but is actually the same. Okay. Okay, so back to what we were doing. We did question 3, so number 4. Okay, number 4. Okay, so we've got the same idea here. On the left-hand side is one single radical. It's already isolated. There's nothing else with it, so we can square both sides. So if we square both sides, we will have 2x minus 4 over 3x plus 4 is equal to 4. A lot of times on tests, people forget to square the right-hand side. So watch out for that. You make sure you always are squaring both sides. They'll write this is equal to 2, and then they solve and they get the wrong answer. Okay, that's one place people go wrong. Cross multiply. So we're going to multiply this out before we rearrange. 4 times 3 is 12. 4 times 4 is 16. Now move things around. You can move the x's to the right so that you have positive x's. It doesn't matter. So 2x minus 12x is equal to, there's already a 16. That minus 4 will become a plus 4. So I get minus 10x equals 20. Divide both sides by minus 10. So we get x is equal to 10 over, or 20 over 10, 2, minus 2. And then we have to check, because the question started with the radical, so we have to check our answer. So always write down the original question. You're going to check in the original. before you change anything. And this one, we don't have to plug it into the right and the left, we just want the left-hand side to equal 2. So you can just figure out the left-hand side and say, yes, it's equal to 2 or no. So we're plugging in negative 2. 2 times negative 2 over 2, 3 times negative 2 plus 4. When you're evaluating a fraction like this, the top separate, the bottom separate, and then divide. So minus 8 over minus 2. And what's it? Minus 8 over minus 2. 4, square root of 4 is 2. They're equal. So minus 2 is the answer. Okay, now 5, and there's one on the homework like this and probably in the textbook examples. The same question, but if I wrote it in the beginning in a different form. These are the same, it looks like the same question. Okay, the numbers are all the same. But the question here is the whole thing is a radical, and here they're separated. Even though you can go from one to the other, this is a classic case of where you get the answer and it doesn't always work in the original question before you change it. So it's legitimate to write this question with a big square root as a second step. But you have to always, when you check your answer, go back to the very original, okay, to the very start. Here, you could do this a different way. You could, method 1 would be to write this as a big square root and then solve that the exact same way we just did. We solved that exact question. What would be another way to do that? If you didn't think to just write it as a big square root and then square both sides and solve, and we get x is minus 2 in the end. We just solved that question exactly. What could you do here? Cross-multiply at the beginning and get rid of the fraction. So here, if you cross-multiplied to start, we would end up with root 2x minus 4 is equal to 2 onto root 3x plus 4. Okay, and that's legitimate. We had a fraction, and you can get rid of the fraction by cross-multiplying. Now if we square both sides, we did a question like this last time. When you square both sides over here, there's more than just the root to square, so you have to square the 2 as well. Here you would have 2x minus 4 when you square it, and here you have 4 onto 3x plus 4. Square the 2, square the root. And we did a question like that last class where there was a coefficient in front or a number in front of the root, and when you square it, you have to make sure you square that as well. And then when we solve this, we still get the same answer we had last time. Wasn't this the equation we had? We switched it around. We had minus 10x is equal to 20, and x is minus 2. You'll get the same thing. Okay, it's just a different way to do it. Now, when we check our answer this time, it's not going to work, though. Even though the question looked the same in the beginning, the answer is no longer valid. So if we were to check our answer, we're plugging in negative 2, but our original question was like this. Now, why won't it work now? Why won't it work this time? Yeah, the square root is just for the top and just for the bottom separate in the beginning. And when we put that negative 2 in, we'll have 2 times negative 2 minus 4. We end up the square root of negative 4 minus 4. which is the square root of negative 8. Already we can stop, it doesn't work. We get a square root of a negative. On the bottom will also be negative. You can't then put these together and force it to work when the original question had them separate, as separate square roots. Then whatever this represented in the real world, it was important that they were separate. And so then the answer doesn't work. Okay, so be careful of that. So what's the lesson is when you check your answer, go back to the original question as it's written on the homework, not anywhere where you changed it. Always check in the exact way that the original was written. Don't check it. So if you had changed this question to here and then you checked your answer in your step, it would look like the answer was right when it really didn't work in the original. Okay. The other place in math where this happens, where you have to check your answer and sometimes it works and sometimes it doesn't, is logs. We do a whole section on logs later, and it's the exact same thing. Why is it the same thing? Well, because you can't put a negative under a square root, and you can't put a negative in a log. So they work very, very similar. If you end up with a negative answer, you can't have it if it doesn't work in the original, but if it does work in the original, then it's okay. Okay, that was 5, 6. So try this one yourself. Square both sides. It's just a two-step question. Solve for x. And what x do you get? Seven over 2? People get that? Okay. And the answer is no solution without checking that. Well, how do I know that? That one's inadmissible. Right. So I told you, do this question, square both sides. What happened when you squared the negative 2, it became a positive 4, and then you were solving a different question with a 4 here. A root, you can't take the square root of a number and get a negative answer. That's not possible. So right away, I looked at this and knew there was no solution. But if you didn't notice that, you cannot take a square root of a number. First of all, you can only plug positive numbers in a square root, and when you get the answer, you know, if you put a 9 in, you get a 3. If you put a 16 in, you get a 4. There's no negative answers either. They're always positive. You plug in a positive number and you get out a positive number, always with a root. So right away, I could say no solution. If you solved it, so this is inadmissible, but you would find that even if you didn't notice in the beginning, you don't have to notice these things, but if you plugged it in, it won't work when you go to check. This is what will we get? So 2 times 7 over 2 minus 3. The 2's cancel. So 7 minus 3 is 4, and the square root of 4 is 2, not negative 2. Right. So this is inadmissible, therefore no solution. So you don't need to notice that it had a negative there and that's no solution right from the beginning, but if you do, you don't need to go through any of this. You just say square root can't be negative, no solution. Right? You can just write beside it no solution with no work. Okay, if you do notice it. 7. Is 0 okay? Yes. Square root of 0 is 0. Without doing any work, tell me the answer. Square root of 0 is 0. What do you plug in here to make this 0? 3. 3 minus 3 is 0? Right. If you square both sides, 0 squared is 0. X equals 3. And your check. And it works. Oops, sorry. Now again, this would be a one-step question that you could just do in your head, but I just want to demonstrate it can equal 0. That's legitimate. It just can't equal a negative. Root 3x equals root 4x. Square both sides. (3x equals 4x). Is that okay? Yes. It is okay. Bring the 4 over. What would be left if you bring everything over? 0. 0. You wouldn't need to go all through that if you notice, but you can plug in 0 here. 3 times 0, 0. 4 times 0, 0 equals 0. I didn't do left-hand side, right-hand side because they were both just really small. It was easy enough to write an equal sign in between and do them. Okay, so I'm going to go back to the start of this chapter. And I just wrote down a couple more to solve that involve rational functions, so fractions. So more rational. Oops. So my question is, do we need a common denominator here because there's one fraction in it? No. If the only fraction that's in it is isolated, which means by itself on one side, we can cross multiply. So how do we cross multiply? Multiply the 6 by the other side, but the whole thing. So we'll have 5x is equal to 6 on to 2x minus 3. And then we solve. 6 times 2 is 12, and 6 times 3 is 18. 5x minus 12x equals minus 18, or bring them to the opposite sides to avoid this negative. Minus 7x equals minus 18. Does that simplify? No. Now, you can't always check your answer. Let's check it because you always need practice with fractions. And this one would be plugging a fraction into a fraction. So you can always check your answer. On a final exam, it's always anywhere you solve for x, you should be checking because then you could fix your mistake, especially if you're prone to silly mistakes. My only advice is check if your check tells you this is not the answer, check your check first. before you go back and erase everything. Do you know what I mean? If you mess up your check, I've seen it so many times on a final exam, they have the right answer, and then they checked it, and their check was wrong. And then they erased everything and put a like big question mark, and I can see it underneath, and I can't give any points. Right, so always check your check first before you dismiss the question. Okay, so let's check it. We don't have to because there's no root in it. There's no x in the denominator of the equation, so there was no numbers that weren't going to work, so the answer, this is going to have an answer. It's just a matter of, did I find the right one, or did I mess up somewhere in here? So the left-hand side, 5x over 6. So this would be 5 times 18 over 7 divided by 6. Not very nice, is it? Now, if you've got a fraction over a fraction, I find what will help you is to make the bottom into a fraction as well. Now, what do we need to do on top? First we say, does 5 cancel with anything on the bottom? And the answer is no. So we do need to do 5 times 18 over 7. And then we have that divided by 6 over 1. It's useful to make sure both are written as a fraction. 5 times 18. How might you do that without writing it out the long way? There's a couple different ways. 5 times 18. This is the same as 5 times 10 plus 8. Do you agree with that? 5 times 10 is 50, and 5 times 8, 40. So 90. That would be one way. The other way that sometimes people will tell me is to say, okay, well, the 18 is 2 less than 20. Did anyone do it that way? So you do 5 times 20 is 100, but then you have to subtract 2 for each one. I find that harder to do sort of in my head or quick. This way is what I usually do, but it doesn't matter whichever way. So this is 90 over 7 divided by 6 over 1. So 90 over 7 times 1 over 6. So 90 over 42. Now, I wouldn't even bother simplifying. It does simplify. I wouldn't even bother yet until you see what you get for the other side. Because if it's nowhere near, you can either check this or reduce, or if it's a reduced fraction, you can say, does it reduce to the same thing? But you don't actually need the answer, and maybe this is the way it's going to look on the right-hand side. So what do we get on the right-hand side? 2x minus 3 was the right-hand side. And what are we plugging in? 18 over 7. So 2 times 18 over 7 minus 3. 2 times 18? 36 over 7 minus, if that's, we want that to be a common denominator, 21 over 7. Subtract 36 minus 21. Okay, and so we would say, is that the same? So maybe, because this does reduce, what would we have to reduce it by so that it looks like this? We want the bottom to be a 7, so we'd have to say, did they both reduce by 6? So 42, that's easy enough. We do know what that is 6 times 7. What about 90? 6 times 6 times 15? Yes, but I'm just thinking of a way. I know people don't like numbers, so I'm thinking of a way I can show you this without you doing too much work. And you may not like this or not, I don't know. Okay, so this is what I would tell my kids. That's what I'm thinking. So how would you know that this is 6 times 15? Still not, I hate like long division and multiplication, so I try to avoid it all the time, just writing down. You could easily do long division, and it would only be 2 steps. It would be really simple, okay? But I do want to show you some things about factors. So where did we get that 90? Do you see it? We already know one thing, and that might have helped us or maybe not. We already know that 90 is equal to 5 times 18. Do you agree with that? We already figured that out. These are the factors. 19 is, say, 6 times 3. Right, so now we actually know that 90 is 5 times 6 times 3. If the 6 cancel, we get 15 over 7. So you can go with something you know, and these numbers are small so it wouldn't matter, but what if the number was 11,056? You multiplied two numbers earlier and got that, and then you needed to divide that 11,056 by a different number. Well, look back, what two numbers did I multiply? And then that's already a start to breaking them down, and you can see what the factors are without doing a whole bunch of long divisions. So sometimes if you already know one, you can use what you know to find a different factor. Because what else is here? 30 times 3, that's 5 times 6, that's 30 times 3, or we could do 15 times 6, or you can do 18 times 5, any combination of these three numbers. And in fact, if we wanted to break that down further, you could do 6 times 15, you could do 10 times 9, right? You can get them all that way. Okay, we have time for another example. So what if we have 4 terms in the original question? So one technique that always works is to isolate the fraction. So leave the x over 3 on one side, move everything to the other side, and then cross multiply. That always will work. What's another technique that you learned? What could you do here that is not cross multiplying? Yeah, okay, you could put them all over 3 as a common denominator, but what's another option? You can actually multiply an equation. If you multiply everything in the equation, you can multiply a whole equation by a number. Why might this help? 3 over 3, that'll eliminate the fraction. I don't usually do it this way, but so you would multiply that. 6x plus 9 equals 3. These cancel, so you have x plus 6x plus 9 equals 3, and then you would solve it. I personally don't like that method because I find people mess it up a lot. Like they'll forget to multiply the 1 by 3. Right? They'll just do one side, not the other. But you can always do that. That's a legitimate way to simplify an expression, is to multiply everything with whatever will cancel it out. When do I use this? When there's complicated expressions involving variables on the bottom. Sometimes I'll just multiply it through, but you can always, so what would the answer be? 7x equals minus 6, so x is minus, just to finish the question. So there would be your answer. But you can always take your question, isolate the fraction, that means get it by itself on one side, see there's a positive 1 and a minus 3, so I could join those together, and then multiply that, cross multiply, and you end up with the same thing. Now what if there's two fractions and then a third thing that's not a fraction, a third term that's not a fraction? So I'll leave that so you can see it. Let's say we had something like this. So my question is, can we isolate one of the fractions and then cross-multiply? No, the only time you could cross-multiply, so if we isolated one of the fractions, you can't cross-multiply here because you can move the 2 up, be multiplied by that whole thing, that would be okay, but you can't multiply the 5 over here because the whole right-hand side would have to be a fraction to be able to do that. So you can only cross-multiply when it's a fraction equals a fraction or a fraction equals a number. Then you can cross-multiply, or a fraction equals a number. But you can't have 2 terms here. That won't work. So what do we need to do to be able to get it in a form so that we can cross-multiply? We have to do a common denominator. So when there's 2 fractions and something else, you do have to combine any 2 of the terms to make it. I would probably just do it from the first step. So what's the common denominator of 2 and 5? 10, so I'd multiply the first one by 5 and the second one by 2. So we'll get 5x over 10 plus 6x over 10. Remember to write the other side. So you're just simplifying this. Then we have a common denominator. We write it over 10. 5x plus 6x, which is 11x over 10 equals 1. And then cross multiply. 10 times 1, 10. Divide both sides by 11. And because there was no radical in the beginning, we don't need to check our answer, although checking will make sure you didn't mess it up. Okay, so that's it for today. So we'll start 1.5 next time.